Accepting command line arguments. Let's create a new project with, as always, cargo new. We'll call our project mini-grep to distinguish it from the grep tool that you might already have on your system. The first task is to make mini-grep accept its two command line arguments, the file name and a string to search for. That is, we want to be able to run our program with cargo run, a string to search for, and a path to a file to search in, like so. Right now, the program generated by cargo new cannot process arguments we give it. Some existing libraries on crates.io can help with writing a program that accepts command line arguments, but because you're just learning this concept, let's implement this capability ourselves. Reading the argument values. To enable mini-grep to read the values of command line arguments we pass to it, we'll need a function provided in Rust's standard library, which is standard-env-args. This function returns an iterator of the command line arguments that were given to mini-grep. We'll cover iterators fully in Chapter 13. For now, you only need to know two details about iterators. They produce a series of values, and we can call the collect method on an iterator to turn it into a collection, such as a vector containing all the elements the iterator produces. Use the code in listing 12.1 to allow your mini-grep program to read any command line arguments passed to it, and then collect the values into a vector. So I recorded the video before the audio. Right now I'm just waiting and watching. Okay, so on the left, this is NeoVim GTK, which is a GUI for NeoVim that is written in Rust. I'm just starting to use it, and I like it okay. At the moment, I am not in the file that I think I'm in. On my file tree on the left, you see that I'm in min-grep source main. But up at the top, you can see the path that I'm in the min-grep directory. I'm going to save this as main, and then have to move it later. Yeah, like it just said, when I saved it, it said main, and it said it was new, so that I didn't notice that. Yeah, so here it's trying to run the main that actually is in the source directory. And sure, I'm doing a lot wrong in this file, but the complaint that Rust is giving me has to do with the other file. It just has the word main in it. So let's see. First, we bring the std-env module into scope with a use statement so we can use its args function. Notice that standard environment args, the function, is nested in two levels of modules. In Chapter 7, we talked about cases where the desired function is nested in more than one module, and how it's conventional to bring the parent module into scope rather than the function. By doing it this way, we can easily use other functions from standard environment. It's also less ambiguous than adding use standard environment args and then calling the function with just args, because args could be something else. Looks like I haven't figured it out yet. Well, I guess I could jump ahead. No, I'll just ramble some. So the font that I've got over in NeoVim is IBM Plex Mono. See, I discovered that I wasn't in the file I thought I was in. I sure do love changing up my fonts. Oh, I see. So what I decided to do was just type it all again, and then I guess I'll go delete the other file. So we're using standard environment. Main function, let args equal a vec of strings. Let args type vec of strings equal env_args.collect. And then we'll print args. And I suppose this is just going to work. And then, yeah, because I got lots of practice typing it before. Print line, yes. The args function and invalid Unicode. Note that standard env args will panic if any argument contains invalid Unicode. If your program needs to accept arguments containing invalid Unicode, use standard env args os instead. That function returns an iterator that produces OS string values instead of string values. We've chosen to use standard env args here for simplicity because OS string values differ per platform and are more complex to work with than string values. One of the reasons I love NeoVim is that it's got a like a terminal built into it. You just give it the term command and it'll open a terminal. And then you can, you're in a terminal in Vim. It's pretty great. Okay, moving along. I'm down at the bottom. On the first line of main, we call environment args, and we immediately use collect to turn the iterator into a vector containing all the values produced by the iterator. We can use the collect function to create many kinds of collections, so we explicitly annotate the type of args to specify that we want a vector of strings. Even though we very rarely need to annotate types in Rust, collect is one function you do often need to annotate because Rust is not able to infer the kind of collection you want. Finally, we print the vector using the debug formatter : Run the code with no arguments and then 2 arguments. Running it with no arguments gives me the value of args, but it's only one string in the vector. It's collected only the file and the binary for min_grp. And I seem to be moving on, so let me stop and read. Notice that the first value in the vector is target debug minigrep, which is the name of our binary. This matches the behavior of the arguments list in C, letting programs use the name by which they were invoked in their execution. It is often convenient to have access to the program name in case you want to print it in messages or change behavior of the program based on what command line alias was used to invoke the program. But for the purposes of this chapter, we will ignore it and save only the 2 arguments we need. Saving the arguments in variables, argument values in variables. Printing the value of the vector of arguments illustrated that the program is able to access the values specified as command line arguments. Now we need to save the values of the two arguments in variables so we can use the values throughout the rest of the program. We do that in listing 12.2. So we say let query equal a reference to args at index 1 and then file name at args index 2, and args index 0 is the binary. Let's see. As we saw when we printed the vector, the program's name takes up the first value in the vector, args 0, so we're starting at index 1. The first argument minigrep takes is the string we're searching for, so we put a reference to the first argument in the variable query. The second argument will be the file name, so we put a reference to the, I don't know. I've started putting extra commas at the ends of my lists, like right there I did it. Rust doesn't seem to mind, and I like it just for its the consistency. I guess it's a little weird. And now, there we go, running it. Yep, need environment variables. So we put a reference to the second argument in the variable file name. We temporarily print the values of these variables to prove that the code is working as we intend. So we'll run the program again with the arguments test and sample text. Searching for test in file, sample text. Great! The program is working. The values of the arguments we need are being saved into the right variables. Later we will add some error handling to deal with certain potential erroneous situations, such as when the user provides no arguments. For now, we will ignore that situation and work on adding file reading capabilities instead. Reading a file. Now we will add functionality to read the file that is specified in the file name command line argument. First, we need a simple file to test it with. The best kind of file to use to make sure minigrep is working is one with a small amount of text over multiple lines with some repeated words. Listing 12.3 has an Emily Dickinson poem that will work well. Create a file called poem text at the root level of your project and enter the poem, I'm nobody, who are you? Root level of the project. Yeah, so not source, but just in the minigrep, file, directory. I'm eating ice cream. So that's that pretty like ls that I used is called exa, and it is a it's part of the the GNU standard utils that have been rewritten in Rust. There's another one called bat that is a variant of cat that I like. It's pretty groovy. I might use it a little. I don't know if I use it in this video. With the text in place, edit source main and add code to read the file as shown in listing 12.4. First, we add another use statement to bring in a relevant part of the standard library. We need standard fs to handle files. In main, we've added a new statement. Fs read to string takes the file name, opens that file, and returns result string of the file's contents. After that statement, we've again added a temporary print line statement that prints the value of contents after the file is read, so we can check that the program is working so far. Let's run this code with any string as the first command line argument, because we haven't implemented the searching part yet, and the poem text file as the second argument, as the second, I don't know. So let's see, I got use standard file fs, I guess that's file system. Let contents equal fs read to string file name dot expect error at read to string semicolon. I guess I could speed it up. Let's try it. Oh yeah, now you think I type real fast. So print line with text contents. Okay, so we're going to run the code with any string as the first command line argument, because we haven't implemented the file searching part yet. And the poem text file is second. Okay, right. Oh, I see. Yes. So we'll look for the word bog in poem.text, and it's going to just print the full text. Lovely. Great. The code read and then printed the contents of the file, but the code has a few flaws. The main function has multiple responsibilities. Generally, functions are more clear and easier to maintain if each function is responsible for only one idea. The other problem is that we're not handling errors as well as we could. The program is still small, so these flaws aren't a big problem. But as the program grows, it will be harder to fix them cleanly. It's good practice to begin refactoring early when developing a program, because it's much easier to refactor smaller amounts of code. We will do that next. Refactoring to improve modularity and error handling. To improve our program, we'll fix 4 problems that have to do with the program structure and how it's handling potential errors. First, our main function now performs 2 tasks. It parses arguments and reads files. For such a small function, this isn't a major problem, but as the program grows, if it grows in main, the number of separate tasks the main function handles will increase. As a function gains responsibilities, it becomes more difficult to reason about it, harder to test it, and harder to change it without breaking one of its parts. It's best to separate functionality so that each function is responsible for one task. This issue also ties into the second problem. Although query and file name are configuration variables to our program, variables like contents are used to perform the program's logic. The longer main becomes, the more variables we will need to bring into scope. The more variables we have in scope, the harder it will be to keep track of the purpose of each. It's best to group the configuration variables into one structure to make their purpose clear. The third problem is that we have used expect to print an error message when reading the file fails, but the error message just prints something went wrong reading the file. Reading the file can fail in a number of ways. For example, the file could be missing, or we might not have permission to open it. Right now, regardless of the situation, we print the same error message, and it doesn't give the user any information. Fourth, we use expect repeatedly to handle different errors, and if the user runs our program without specifying enough arguments, they will get an index out of bounds error from Rust that doesn't clearly explain the problem. It would be best if all the error handling code were in one place, so future maintainers had only one place to consult in the code if the error handling logic needed to change. Having all the error handling code in one place will also ensure that we're printing messages that will be meaningful to our end users. Let's address these 4 problems by refactoring our project. Separation of concerns for binary projects. The organizational problem of allocating responsibility for multiple tasks to the main function is common to many binary projects. So, the Rust community has developed a process to use as a guideline for splitting the separate concerns of a binary program when main starts getting large. The process has the following steps. First, split your program into a main and a lib, and move your program's logic to lib. As long as your command line parsing logic is small, it can remain in main. And third, when the command line parsing logic starts getting complicated, extract it from main and move it to lib. The responsibilities that remain in the main function after this process should be limited to the following: calling the command line parsing logic with the argument values, setting up any other configuration, calling a run function in lib, handling the error if run returns an error. This pattern is about separating concerns. Main handles running the program, and lib handles all the logic of the task at hand. Because you can't test the main function directly, this structure lets you test all of your program's logic by moving it into functions in lib. The only code that remains in main will be small enough to verify its correctness by reading it. Let us rework our program by following this process. Extracting the argument parser. We'll extract the functionality for parsing arguments into a function that main will call to prepare for moving the command line parsing logic to lib. Listing 12.5 shows the new start of main that calls a new function, parseConfig, which we will define in main for the moment. We're still collecting the command line arguments into a vector, but instead of assigning the argument value at index 1 to the variable query and the argument value at index 2 to the variable filename within the main function, we will pass the whole vector to the parseConfig function. The parseConfig function then holds the logic that determines which argument goes in which variable and passes the values back to main. We still create the query and filename variables in main, but main no longer has the responsibility of determining how the command line arguments and variables correspond. This rework may seem like overkill for our small program, but we're refactoring in small incremental steps. After making this change, run the program again to verify that the argument parsing still works. It's good to check your progress often to help identify the cause of problems when they occur. Grouping configuration values. We can take another small step to improve the parse config function further. At the moment, we are returning a tuple, but then we immediately break that tuple into individual parts again. This is a sign that perhaps we don't have the right abstraction yet. Another indicator that shows there's room for improvement is the config part of parse config, which implies that the two values we return are related and are both part of one configuration value. We're not currently conveying this meaning in the structure of the data, other than by grouping the two values into a tuple. We can put the two values into one struct and give each of the struct fields a meaningful name. Doing so will make it easier for future maintainers of this code to understand how the different values relate to each other and what their purpose is. Note: using primitive values when a complex type would be more appropriate is an anti-pattern known as primitive obsession. Listing 12.6 shows the improvements to the parse config function. I keep that comma after in the struct fields. Well, actually there's, do you spot the error? Do you spot the typo? After file name though, I have, after file name's string type, I have a comma there. You know what? I didn't put a comma after, did up top searching for query, and then I put a comma after it. I didn't put one after file name in this config struct instance. So what are we fixing here? So expected a colon and found a comma. Oh, that's down there. Yep. And then we got mismatch types. Alright, because I had to finish changing main. So now we're letting config equal running parse config on args, and it produces, we're calling it config because it is an instance of a config struct. So we got that going on. Yeah, I wasn't sure about this error, so I tried to just run it. I think I forgot. What did I forget? Okay, I expected a struct and found a reference. This looks like, oh, there it is. Yeah. Great. So we have added a struct named config, defined to have fields named query and file name. The signature of parse config now indicates that it returns a config value. In the body of parse config, where we used to return string slices that reference string values in args, we now define config to contain owned string values. The args variable in main is the owner of the argument values and is only letting the parse config function borrow them, which means we'd violate Rust's borrowing rules if config tried to take ownership of the values in args. We could manage the string data in a number of different ways, but the easiest, though somewhat inefficient, route is to call the clone method on the values. This will make a full copy of the data for the config instance to own, which takes more time and memory than storing a reference to the string data. However, cloning the data also makes our code very straightforward because we don't have to manage the lifetimes of the references. In this circumstance, giving up a little performance to gain simplicity is a worthwhile trade-off. The trade-offs of using clone. There's a tendency among many Rastafarians to avoid using clone to fix ownership problems because of its runtime cost. Later, we'll learn more efficient methods in this type of situation, but for now, let's just copy a few strings and continue making progress, because you'll make these copies only once, and your file name and query string are very small. It's better to have a working program that's a little inefficient than try to hyper-optimize code on your first pass. As you become more experienced with Rust, it'll be easier to start with the most efficient solution, but for now, let's just clone. We've updated main, so it places the instance of config returned by parse config into a variable named config. And we updated the code that previously used the separate query and file name variables, so it now uses the fields on the config struct instead. Now our code more clearly conveys that query and file name are related, and that their purpose is to configure how the program will work. Any code that uses these values knows to find them in the config instance in the fields named for their purpose. Creating a constructor for config. So far,